again, math friends. Welcome to a new episode. Today we're going to be looking at solving and graphing basic inequalities. Well, let's talk about what an inequality is. It is a relation that makes a non-equal comparison between two expressions. In other words, it's sort of like an equation, but instead of an equal sign, we have an inequality sign in between the expressions. In order to solve an inequality, we do the same thing we do when we solve equations. We isolate the variable on one side of the inequality and get everything else on the other side. So let's jump in and look at a few. In this first one, I want to get x by itself, so I need to subtract 2 from both sides because that 2 is positive. If I do that over here, I must do the same thing over here. And here these add out. I'm left with an x greater than 5 minus 2 is 3. So what this is saying is that all of our x values have to be 3 or larger, bigger than 3, in order for this statement to be a true statement. If we put something in that's less than 3, our statement up here would not be true. All right, that's the solution. If we want to write the solution set, there are a couple of ways that we can do that. First is to use what is called set builder notation. And it looks like this. We write the set of all x such that x is greater than 3. So that's writing the solution set in what is called set builder notation. Then we're going to write also in what is called interval notation. But before we do that, I'm going to graph this inequality, solution to this inequality first, because it'll make the interval notation make more sense. So all of our values of x have to be from 3 and bigger. So if we graph that on a number line, it would look like this. In interval notation, we look at endpoints of our solution. This solution, the endpoint is at 3, and since we are including 3, we're going to write a bracket. This endpoint is 3, comma, and then this endpoint. Well, this endpoint never ends. It continues to go, so we say that it goes to positive infinity, and since positive infinity is not a tangible endpoint, we can't say that we include positive infinity, so we write a parentheses. So this is what interval notation looks like. You may also see the inequality graphed in this fashion, where they put a bracket to include 3 and then graph everything to the right. All right, let's take a look at this one. We want to get the y by itself. So since we're subtracting 6, I'm going to add 6. If I do that over here, I must do that over here. Over here we get negative 1. Over here the 6's add out. Now we divide by 4. Divide by 4. 4's divide out. We're left with y. And we get negative 1/4. This is also the same as y is greater than negative 1/4. Okay, in set builder notation, this would be written the set of all y such that y is greater than negative 1/4. Let's graph it. Negative 1/4 is going to be roughly right here, but since we're not including negative 1/4. That should be an open circle. Let's draw that a little better. And then we have everything to the right. Now, in interval notation, since we're not including the negative 1/4, we put a parentheses because that is not included, and so we put a parentheses for non-inclusion, and then this continues to the right, so it goes to positive infinity, which we do not include. You will also see the graph drawn in this way. Since we're not including negative 1/4, we put a parentheses and then graph. So either way, depends on your teacher and the textbook that you're using. Some will use one method, others will use a different. Okay, in this example, we've got x's on both sides. We still do the same thing as if this were an equal sign. I'm going to subtract 2x from this side because it's positive. And so I have to subtract 2x from this side. Over here, these add out, and I'm left with negative 7. 4x minus 2x is 2x plus 3. Then I'm going to subtract 3. So I have to subtract 3. These add out. I'm left with 2x. Over here, negative 7 and negative 3 is negative 10. Now I'm going to divide by 2. Divide by 2. These divide out. We're left with x. And negative 10 divided by 2 is negative 5. This can also be written x is greater than or equal to negative 5. We typically like to write inequalities with the variable on the left and the constant amount on the right. In set builder notation, the set of all x such that x is greater than or equal to negative 5. If we graph this, we are including negative 5, so we put a closed circle, and everything larger, again, is to the right. Interval notation, we are including negative 5, so that's the endpoint on this side, and we're going to positive infinity, which we do not include. And then again, sometimes you will see this drawn as a bracket. All right, over here on this side, I see some warning signs. Something different's going to happen here. Let's see what that is. Here we've got to subtract 4 from both sides. The 4's add out. We get negative 9x. Greater than 11 minus 4 is 7. Now we need to divide by a negative 9 and divide by a negative 9. There is a rule with inequalities. If you multiply or divide by a negative number, the inequality has to flip over. And so since I'm dividing this side by negative 9 and this side by negative 9, the inequality has to flip over, and we get the negative 7/9. X is less than negative 7/9. Set builder notation, set of all x such that x is less than negative 7/9. If we graph this, we have an open circle at negative 7/9, which is not quite at 1. And this time we have everything to the left. In interval notation, since the left endpoint is going forever in the negative direction, we don't include, but our endpoint is to negative infinity, and on this side negative 7/9, and we're not including. And then once again, you may see this written as a parentheses and then the rest. All right, let's look at this one. Here I need to first of all distribute my -3. So -3 times 4 is -12x. -3 times -5 is +15, greater than or equal to -2. Then I need to subtract 15. Subtract 15. Here the 15s add out. I get -12x. -2 and -15 is -17. Then we need to divide by -12. And because I'm dividing by a negative, this inequality has to flip over. And we get +17/12, which is also 1 5/12. So in set builder notation, this becomes a set of all x such that x is less than or equal to 1 5/12. To graph this, 1 5/12 would be just past the 1, and we want everything less than that. So in interval notation, we're going from -infinity to 1 5/12, and we are including 1 5/12, so we use a bracket. And again, our graph, instead of doing it that way, you may see it drawn that way. All right, let's look at another one. On this one, we need to take the 2 and distribute, so I have -5y plus 2 less than 2 times y is 2y. 2 times -1 is -2. Then I'm going to add 5y to this side. And I'm going to add 5y to this side. Over here, the 5y's add out. I get a 2. 2y and 5y is 7y. Now I'm going to add add 2 to this side, add 2 here, these add out, left with 7y, it's 4. I'm dividing by +7, so the inequality does not flip. But I'm going to turn this whole inequality over. And write it as y is greater than 4/7. So the inequality didn't really flip. I'm still looking at y values bigger than 4/7. I'm just writing it in a different form. Set builder notation, set of all y such that y is greater than 4/7. +4/7 would be somewhere in here. Everything larger. So we have an open circle since we're not including. So our interval notation, we're not including 4/7, and we're going to +infinity. And then again, you may see this drawn with a parentheses instead. All right, that wraps it up. Thank you again for watching. Check out all of our videos on our YouTube channel and make sure you subscribe. We have tons of free interactive math activities on our website, edtech.dnjdesigns.org. Check it out. Lots of good drill and practice there. Thanks again for watching, and we'll see you on the next episode.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.